Friends, I'm Mohnish and you're watching Codex Mohnish. So today we are going to discuss about the semantic ladder sensors. So in our last video we had discussed about the ladder sensors. So if you have not seen that video, you can go back and see the video. And now let's jump to our topic. So this is the code which we have written here. So this is the same story which we have in all videos, and now we'll just get to our try block. So we are just calling the client, we are getting the world, and we are getting the blueprint. We are getting the model 3, and then we are spawning. We are setting the spawn point, and we are dropping the vehicle and setting the autopilot. Then we are getting the location and rotation, like of the camera simulator. So it's like how much far we should get when the car spawns. So here, if a car spawns, if you are somewhere in the world, like other corner of the world, so it will just teleport you to that location with 30 meters in the front direction. So this get forward vector does that. And then yaw. So in the camera we have 3 position: pitch, yaw and roll. So we'll just, that's a topic for another class, like another video, so we'll see that also. And then we are setting this as a spectator, so it will just see what's happening, and we are just appending all that to the actor list. And here we have the ladder sensor, so we are generating ladder blueprint, so we are calling a function here. So let's have a look at the function which is pre-written here. So here we are here last video we had used sensor the lidar the raycast, but here we are using the raycast semantic. So the difference between semantic lidar sensor and all that, like semantic is just better, like it gives you a wider range, it gives you the color maps like more accurately, and it has a, like the main problem with the lidar raycast, like only lidar, is it gives you a clear view at the x level, like at x axis, but at the y axis it doesn't work properly. So here we are having the semantic lidar sensor, which also gives us the y axis labels, like we can accurately measure like y axis. So that's a big breakthrough in the lidar and the semantic lidar. And then we are setting the channel 64 points per second. So here we are just multiplying 56,010, it means 5,60,000 points per second rotation frequency. So I'll repeat again that rotation frequency means how many times the lidar is going to rotate in 1 second. So here the lidar is a sensor which will emit laser beams, and it rotates real fast on the car top. Like we'll just think this is the car top, this is the lidar. It rotates. It sends laser beams and waits for it to get received, and then it will we'll get the data. And so that points per second, so that points is the data which we collect. So we'll get 5,60,000 points as our data, and we are setting the range. So this is like a range of how many meters range you want, so you can see that. And upper FOV, lower FOV. So this is a FOV, so we don't care much about the FOV here. And just we are returning the ladder sensor, of course. And then let's jump back here, and we are setting the spawn point and all that, pitch and raw, like location. Okay, so here I just go -0, so I'll just do minus off. And then rotation, we are setting the pitch, yaw and roll to 0, 0 and yaw to 90. So yaw is like this. And then we are just spawning the lidar sensor at that location, and we are attaching it to the drop vehicle. So that's real simple. And then we are having the lidar figure. So here, what do you mean by the lidar figure? So the lidar figure here is like the blueprint or the visualization in 3D which we are going to get. We are using MLab from Mayavi. So we have imported it here. So from Mayavi, import MLab. So that's the library we are using. And then we are making the figure size. This is the dimensions, and this is the beiging background color. This is almost white, I think. And then we are pointing the 3D. Like I still don't know what this parameters means, like I have to still study them. But this mode means point. So here we're having mode. So here it will represent a data on the 3D graph in the form of points, and this is a color map. As you know, there are many color maps. If you have worked in Matplotlib, then you know what are color maps. So here the color maps which are scaling from 0 to 1 mostly. So towards 0 you have a color, and towards 1 you have another color, and between the 0 and 1 transition you have the shades of the color. So you can visualize it like that. So we are having a GNU plot color map here, and we have figure. What's the figure it should show? So that's the LiDAR figure, so which we have defined here. And then we are just viewing it, mlab.view, and we are just intensity and all that, we are just setting that. And then we are calling the sensor.listen function the semantic LiDAR data. So we are getting the LiDAR from the sensor.listen. So sensor here is this one which are spawning. So the sensor holds the LiDAR, and then we are calling this function. So let's get to this function. Find. So yes, now you see here we are having a matrix representational data. So this from buffer, you see np.from buffer. So np is numpy. So from buffer will make this multi-dimensional array into one 1D array. So it will help us in processing. And we are just point cloud.raw data. So we got this, no, like this one, point cloud. So from that we are getting the raw data. Raw data is one attribute to this class, and we are setting the d type for x to float, for y to float 32, and z for float 32. Then we are having the cos angle. So this is the angle at which it's incidenting and reflecting, so we get the angle. Then object index and all that, object add, that's not so much required here. And then we are making array of x minus y and z, and we are printing the matrix as representational data, which we are of course going to check. And we are setting the object tag data type to float 32 after this matrix representational data is made. And then we have made a dictionary here. So I think we have defined it somewhere here. I think no, we have not defined it. So this is a dictionary which we are getting as an argument. In that we are setting the points, like PTS as a key. In that we are setting the data into the LiDAR points, which is the XYZ array of the LiDAR points which you have got. So where it should plot XYZ axis, so it will plot it that point in the 3D graph. And we are having an intensity, like what's the intensity there. Like if you see, for example, red is very near and green is very far. So red is the intensity of the data here, for example. So that, like, we can just say the intensity like that if you visualize. And then labels, so this is the labels which we have created. So that's the object tag. And then we are having a loop threading. So we just want to perform the task multiple times. Like Python performs one task at a time, but using threading we can make Python perform multiple tasks at a time, at the same time, more importantly. And then this is the handling function which we are calling here. So you see we are calling the loop thread, Scala threading loop. You see the parameter word, and then arguments for this is word, dame and true, and we are starting it, and we are just appending the sensor, and we are 1000 seconds. And after we do Control C for stopping the program, so it will destroy the cars, and that's it. And that is the simple program we have made. Okay, so I'll just clear this output, CLS. I'll just make the screen a little big, and we'll just run this file in the car. So it's going to take time, of course, because this is not a so fast PC, so it takes time to load, and we are going to wait patiently. So meanwhile I'll just say use that. So here what is the Maya doing? So here it's just trying to create a video like of the LiDAR sensor. Like progressively we are getting the data, so car is moving, so progressively our data is changing. So we need to get that data and we need to show it in Maya. The data is changing, but we get an illusion that it's a video. but actually it's not a video. So we are just getting the pictures very fast, like pictures come, and then the pictures as like we go from one picture to another picture smoothly, and it acts like a video. So from 1 to 10 pictures we are going in 1 second. So you see it's in a video form. So that's an illusion that is made. So many pictures are stored in the new folder, and those are shown like one after one, and that creates the illusion of a video here. So that's all. So you're getting the MyWay screen here, and this is our LiDAR sensor. So you see the GNU point color map is like purple is near, and you see this, and this is the range of I think 200 meters. So you see this is our car, the small black thing here. And so in the previous video, if you see, we are not able to get how height, like what's the height of the things here. Like we are only getting the data and along the x-axis. So here we are getting the data along the y-axis also. You see the walls are perfectly shown here, and then we are having like nearby things. So here we are having the trees and all that. So the car is moving front. If you see, we are flexible with this. We can move it here, and so we see the data getting saved. So we are already done with 50 PNGs saving in this small time. So we'll just change the directions and get the looks. So you see this is how the ladder looks. So you see this is another subway, I think. Not subway, kind of like it's just going in through there. So this is how a semantic LiDAR looks like. So we can say the semantic LiDAR is just more accurate or just more useful than a normal LiDAR, but it may slow down sometimes because of course better things take more resources. And then that's it for the video, friends. Thank you for watching the video, and don't forget to like this video and subscribe to this channel. We'll be coming with more exciting videos. Still then, take care. Bye bye, friends.